Alright gang, here we go. This is for Physics Unit 10 Part 2, talking about magnetism and electricity. Alright, so this should be nice and short and sweet, easy video here. So first part we talked all about magnets, talked a little bit about magnetic field, magnetic flux, some new material, all right, but mostly building on stuff you should have had a firm grasp on from previous science classes. Now part 2 we start to integrate what we learned last unit about electricity and what we are currently learning about magnetism. All right, so there's this weird thing that happens if you take a wire and you run a current through it, and you put like a compass next to it. That compass will actually get deflected, so it won't point north anymore, and it'll actually get deflected, so it's no longer pointing north. And if you take a bunch of them, put them around the ring, you'll actually form this this circle. Right, and you'll see how these compasses are all pointing in a different direction here, and they're all pointing in. You could try and draw a circle here, and they're all drawn in a circle. All right, and so what occurs here is that what we see is an indication that a wire that's carrying a current actually forms a magnetic field, and we can use what's called the right-hand rule to determine what the magnetic field is or what the current is based on the magnetic field. All right, so in order to do the right-hand rule, you make a thumbs up. Okay, you imagine you're grabbing the wire, okay, and you point your thumb in the direction of the current, and then the way your fingers curve is the direction of the magnetic field. All right, it's pretty simple, right? There's another right-hand rule we'll learn next video, but for now this is the one we're running with, and then we'll use right-hand rule version 2. But anyway, so right-hand rule, thumb with the current, you grab the wire, wherever your fingers are curving is where the magnetic field. So pause the video and give it a shot. See if you can, and get a an idea of what your fingers are doing. So you notice down here that you cut this magnetic field is curving. Okay. All right. So let's give it a shot. We're looking at this funky shaped wire. This wire is in like a loop here towards the end, and we want to use the right-hand rule to determine the direction of the magnetic field at these different points. All right. So if we take our thumb, our hand, and we imagine that it's here on the eye, remember, so we're going to stick our thumb facing this direction as we go because that's the current. All right. And so as we get to A, okay, we'll see that our our fingers, if we put our thumbs facing this direction here, our fingers curl up and over this way, right? Kind of like almost a clockwise motion. And so remember like so let's do it here, like looking straight on real quick. Oh, that was a little bigger than I meant it to be. Let's erase this guy right quick. And so if we take, all right, so let's do it here, and then we'll try to draw it in 3D. All right, so if we're here at our A point, this is our A. If we were going to draw our magnetic field, remember our magnetic field, if it's coming out of the page, we draw a circle, and if it's going into the page, it's an X, right? So anyway, so here's our point A. So our current, maybe we should notate that our current is going this way. All right, and coming out this way. So anyway, so our current is going this way. Stick our thumb here. So it's going to be coming out of the page. So we'll draw a circle here for that part. And then it's going to, oh my gosh, and then it's going to be going into the page over here. All right, and then if we do B, right, we've moved over here to B. I really don't like how it does this. But anyway, so here's B. And then down here, okay, thumb is still facing this direction, going from here to here, and so we get a dot right here for that, and then an X over here. And then at C, same idea, right? We get this guy here, and so we get a circle over there, and we get an X over here. All right, and so you could see, like, well, shoot, dang, no matter where I am, the current is always going to be going in the same direction. It's always going to be coming in from the center of the circle and then back around down towards the outside. So at the center of the loop, the net field would be coming right out at us, right? It'd just be this coming right out at us. All right, and we could try to draw this here, and you're going to see how bad I am at drawing now, but that's all right. And so this curve, right, our fingers curve this way, so it would come up and over like this, and then come around. Now remember, magnetic fields always form a closed loop, right? So it would do something like that, okay? And because our fingers curve this way, we draw arrows going like this. For B, right, our B value it'd be coming up and over like this, and then come back down around there, and then come up here like this, right? That would be our B. Yep, 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 yep. Right? And then for C, same idea, right? It would come up from C around down like that, right? And then through the middle, we'd get a curve that does kind of like this, right? And it would probably like curve back into the screen somewhere like that. But anyway, all right, so there's our curve, okay? So we can see that this is kind of what happens when we have a loop. Now, if we have a loop running a current through it, we get a magnetic field that looks like this. And this looks very, very similar to what we witnessed when we were looking at a magnetic field. And so essentially what happens is we can create a magnet by just making loops of wire, okay? And these are called solenoids. All right, so solenoids are coils of wire, and they just do loop after loop after loop. The more loops you have, the stronger your field's going to be. All right, the more current you have, the stronger your field's going to be. We can also make this field a lot stronger by putting a piece of iron in the middle. We call this electromagnet. And essentially what this is doing is, just remember, iron can be magnetic, but it doesn't hold the magnetism very well, but you can induce magnetism on it quite well, or quite easily. So by putting a piece of iron in here, then you can actually create a magnet, and we call these electromagnets. All right. So maybe you've made one of these, maybe not. If you take like a bolt made out of iron and you wrap it in wire, and then you connect that wire to a battery, you have quite a strong magnet right there, because you're creating a magnetic field with all those coils of wire. The more coils you have, the better it is, and the more current it has, the better it is. Okay, and that's it for this little bit here about electricity causing magnetic fields. All right, make sure you do your practice problems on here. The stuff here is not hard, but it does take some practice running with the right-hand rule and trying to get an idea of where these magnetic field lines are pointing, so on and so forth, and being able to predict behavior. All right, so anyway, so do your practice problems. Let me know if you have any questions, and I'll see you on the flip side.